Students, how are you all? Hope you all are safe and fine at your home. So students, welcome back in your mathematics class. This is class 9th, chapter 9, area of parallelogram and triangles. So students, today we will take your revision 2 from this chapter. So student, this is our revision 2. In this lecture, we will discuss some important questions of exercise 9.3 and the remaining questions of exercise 9.4, which is optional. So students, ready for today's lecture? Question number 5 from exercise 9.3 is most important question. In this question, what is given to us? A triangle ABC given to us. D, E, F are the midpoints of the sides of a triangle ABC. We have to prove that first part BDEF. BDEF is a parallelogram. Second part DEF, area of DEF is 1/4 of the triangle ABC. So students, and third part is area of BDEF is half of the area of ABCD. For this we will start our proof that in triangle ABC, E and F are the midpoints of AB and AC according to the midpoint theorem. You remember what is midpoint theorem? The statement of midpoint theorem was that if we have two midpoints in a triangle ABCD, when a line segment which joining the two midpoints of any two sides of a triangle is parallel to the third side and half of the third side. So EF parallel BC and EF is equal to half of BC. Similarly, EF is parallel BD because BD is a part of BC and half of the BC is BD. So EF is parallel BD and EF is equal BD. So student, hence BDEF is a parallelogram. Similarly, we can say that EFDC and AFDE are also parallelogram. If it is a parallelogram, so similarly it is also a parallelogram and it is also a parallelogram. We know that the diagonal of a parallelogram divide it into two triangles of equal area from the 8th chapter. So area of triangles, area of triangle BDF and area of D, similarly area of DCE and area of DEF are also equal. Equation number 2, area of AEF, area of DEF, equation number 3. From equation number 1st, 2nd and 3rd, or area of all the triangles are equal to each other because they all are equal to the same triangle. So they all four triangles are equal to each other. If the four triangles are equal to each other, then we know it very well that area of ABC is equal to area of DEF plus area of BDF plus area of DCE plus area of AFE. So we know all four areas are equal to each other, so we can replace all four with any one triangle. So I choose replace with the triangle DEF. So we have now four areas of DEF. When 4 is here in multiplication, when we will shift to the other side, it will be in division. So area of DEF is equal to 1/4 of area of ABC. Now the third part of the question, we know it very well that area of BDEF, area of BDEF is equal to area of DEF plus area of BDF. Area of DEF plus area of DEF, we can replace it. This is the 1/4 of ABCD. This is also 1/4 of ABCD. When we will add them, this is half of the area of ABCD. This is our third part. Question number 7 from exercise 9.3 is given a triangle ABCD and it is given that area of DBC and area of EBC are equal to each other. We have to prove that they both are lie between same parallel. They both are present on a common base. It is clearly visible, but we have to prove that they both are lie between same parallel. So in triangle ABC, the area of these two triangles are already given. They are equal to each other. It is half into base into height. It is also half into base into height. In DBC, base is BC and height is DP. Height is DP. In EBC, base is BC and height is EQ. So when we will solve this theorem, so half is cancelled with half, BC is cancelled with BC, so the remaining part DP and EQ are equal to each other. If the distance between two line segments are equal, then they are parallel to each other. I've already proved this with the theorem also in revision 1. So BC parallel DE, BC parallel DE. This is very easy question. Now question number 8. In question number 8, Question number 8 is XY is a line parallel to a side BC of a triangle ABC. And now if BE is parallel, we have to produce B to the point E. BE is parallel to AC and CF is parallel to AB. And when we will meet these 2 points E and F at point A. So we have to prove that area of this triangle is equal to area of this triangle. So what is given to us? XY parallel BC, BE parallel AC and CF parallel AB. We have to prove that area of ABE is equal to area of ACF. So for this proof we will start. XY parallel BC given, EF parallel BC. If EF parallel BC, so definitely EY, which is a part of EF, is parallel BC, and XF is also a part of EF, is also parallel BC. BE parallel AC, BE parallel YC, CF parallel AB, CF parallel XB. They both are the parts of these two sides. Hence, EBCY and XBCF are parallelograms. If they both are parallelograms, both parallelograms are lie on a common base BC and lie between the same parallel BC parallel BF. According to the theorem, we know it very well that the area of these two parallelograms are equal to each other. This is our equation number first. In triangle AEB and parallelogram EBCY, they both have a common base EB. They both have a common base EB and they are lie between two parallel lines EB parallel AC. So area of triangle ABE is equal to half of the area of parallelogram. Similarly, we can prove that for the another part of the triangle, which is ACF, half of the area of X by XBCY, but they both parallelograms are equal to each other from equation number first. So from equation number first, second and third, the area of these two triangles are equal to each other. This is our equation number 8. Next is equation number 9 from your NCERT exercise 9.3. So question number 9 is that the side of a parallelogram ABCD is produces to the point P. A line through A is parallel to CP, which is AQ, and the parallelogram PBQR is completed. Show that area of ABCD and PBQR are equal to each other. So we have two parallelograms are given in it. CP parallel AQ is also given. We have to prove that area of two parallelograms are equal to each other. For this proof, in triangle ACQ and APQ are on the same base AQ and CP parallel AQ. According to the theorem, triangle ACQ and area of triangle APQ, equation number first. Subtract area of triangle ABQ from the both side. Now we have subtract ABQ on the both sides. So the remaining part is ABC and PBQ. ABC and PBQ. So the double of PBC and double of PBQ is parallelograms. How they are parallelograms? If we will check from your diagram, area of ABC. First of all, we will choose these two triangles, and then congruent area of these two triangles are equal on the common base and between the same parallel. Then we will subtract this area from the both sides. So the remaining part is area of ABC and area of PQB. In these two triangles, both triangles are present in first in this parallelogram and second one in this parallelogram. So the double of this triangle is this parallelogram and double of this triangle is this parallelogram, because we know that diagonal of a parallelogram divided into two triangles of equal area. So definitely we will multiply our given equation with 2. So it is parallelogram ABCD and it is parallelogram PBQR. So area of parallelogram ABCD is equal to area of parallelogram PBQR. It is proved. Question number 13 is also very important. The question is ABCD is a trapezium in which AB parallel DC, a line parallel to AC, intersect AB at point X and BC at point Y. We have to prove that area of triangle ADX and area of triangle ACY are equal to each other. So students, a trapezium is given, two lines are parallel given. So we know it very well that in triangle ADX, this triangle ADX and ACY, they do not have any common base lie between same parallel. So we will choose another triangle which have a connection with these two triangles. So in triangle ADX and ACX, ADX and ACX, they are present on a common base AX and lie between two parallel AX parallel DC. So area of these two triangles are equal. In triangle AXC and ACY, AXC and ACY, they have a common base AC and they are lie between same parallel AC and XY. So area of these two triangles are also equal. So we will write like this, that in these two triangle common base lie between the same parallel, and the area according to the theorem area of these two triangles are equal, equation number first. And the another two triangles, they have a common base lie between the same parallel, area of these two triangles are also equal, equation number 2. From equation number 1 and 2, area of these two triangles are equal to each other. So student, this is your question number 13. Now question number 14. This is also a very easy and important question. Question number 14, it is given that AP parallel BQ parallel CR. We have to prove that area of AQC and PBR are equal to each other. So student, it is very easy. AQC is present in between two triangles ABQ and BQC. Similarly PBR. So in this trapezium, we will choose two triangles with the base BQ. They both triangles ABQ and PQB, common base BQ, lie between two parallel lines which is already given to us. So area of these two triangles are equal to each other, equation number first. Now in the lower trapezium, we will choose triangle BCQ and BQR with a common base BQ and lie between same parallel. So they both are equal in area, equation number 2. And then we will add these two equations and we will get our result. So student, try to solve this question. So student, this is exercise 9.4 from your NCERT, question number 6. We already discussed first 5 questions. So question number 6 is diagonal AC and diagonal BD of a quadrilateral ABCD intersect at point P. We have to prove that area of all 4 triangles are equal with the combination of 2 triangles. So what is given to us? ABCD is a quadrilateral whose diagonal is intersects at point P. We have to prove that area of APB and area of CPD. APB and CPD and the product of these two triangles area is equal to the product of APD, area of triangle APD, and the area of triangle PBC. We have to prove that. For this, we will draw two perpendiculars. First of all, we will draw a perpendicular AE which is on BD, and second one is CF which is also on BD. So first of all, we will take left hand side's area of triangle APB into area of triangle CPD. We know it very well that area of triangle is half into base into height. So half into base for the APB is PB and height is AE. For CPD base is DP and perpendicular is CF. So we will put all 4 values. Now we have 1/4 PB into AE into PD into CF. Similarly, we will take right hand side of the question, which is area of APD multiplied by area of PBC. So half into base into height, half into base into height. For this triangle, base is PD, height is AE. For this triangle, base is PB and height is CF. So which is also equal to 1/4 of PB into AE into PB into CF. So if you are able to recognize that these two parts are equal to each other, so left hand side is equal to right hand side. We have to prove this only. So student, this is your question number 6. Now question number 8, which is the look like a most difficult question, so pay attention here, but it is very easy question. Question number 8 from exercise 9.4 from your NCERT, we have a triangle ABCD which is a right angle at point A. This is a right angle triangle at point A. Now we have 3 sides AB, AC and BC. All 3 sides we will draw squares. We have squares. So it means all sides of squares are equal to each other. So we have one square here, second square here and third square here. So our diagram is look like this. So student, this is your diagram which is given in your 8th question. And now first part is we have to prove that triangle MBC triangle MBC is congruent to the triangle ABD. So first of all, we will choose a triangle M. M is here, MBC. It means in this triangle, and ABD, ABD, in triangle ABD. Now we do not have any common thing between triangle AMBC and ABD. So students, we need, for the congruency, we need three elements between these two triangles. So let me check. ABMN is a parallel square, we know it very well, and similarly it is also a square, it is also a square which is given. In MBC and triangle ABD, first thing is MB is equal to AD. MB is equal to AD, because they both are the, MB is present in this triangle, AD is present in this triangle, but they both are the sides of same square. They both are the sides of same square. In second thing is BC is equal to BD. Similarly, they both sides are present in a same square, but this side is present in this triangle and this side is present in this triangle. Now we have two different sides. We have, because it is a 90-degree angle, it is a 90-degree angle because it is a square, and it is also a 90-degree angle because it is a square also. We have X here, let it is a X. So in triangle MBC, this angle is 90 plus X, and triangle ABD, this triangle is also 90 plus X. So third thing is angle MBC is equal to angle ABD. They both are equal to each other, 90 plus X. So definitely by angle, sorry, side angle side, side angle side, by SAS, both triangles are congruent to each other. By CPCT we can use two things in it, like MC is equal to AD by CPCT. So student, now the second part of the question is, so student, second part is we have to prove that area of BYXD is equal to the double of area of MBC. BYXD and MBC do not have any relation. So we will take ABD in replace of MBC, because in first part we know it very well that ABD and MBC are equal in area. So we will do this question with ABD, and then at last we will replace it with MBC. In triangle ABD and B in parallelogram BYXD. Now you are thinking that how I said that it is a parallelogram. Yes, definitely it is a parallelogram. It is given that this is parallel to this and this is a square. So this part is parallel to this. So the opposite sides are parallel. So definitely it is a parallelogram. So in this triangle and this parallelogram, we have a common base BD, and they are lie between two parallel lines, BD parallel YX. So definitely if BD parallel YX, so BD parallel AX. So in triangle ABD and parallelogram BYXD, they have a common base BD, and they are lie between two parallels, which is BD parallel AX. So area of parallelogram, area of triangle ABD is equal to half of area of parallelogram BYDX. So this is our equation. Now with the theorem we can replace it with area of triangle MBC, which is equal to half of the area of BYDX. When we will 2 is present here in multiplication, when we will shift to the other side it will be present in division. So we will get our answer. This is your second part. So the third part of the question is we have to prove that area of BYXD is equal to the area of ABMN. We have to prove that area of these two parallelograms. This is also a parallelogram because all squares are parallelogram. So we have to prove that these area of these two parallelograms are equal to each other. I already proved that MBC is double of the area of BYXD. If I proved with this ABMN the same thing, then we can say that they both are equal to each other. So ABMN and triangle MBC C. They both are present on a common base MB. They both are present on a common base MB, and MB and NC are parallel to each other also. So students, according to the theorem of a common base and lie between same parallel, area of triangle MBC is equal to the half of area of parallelogram ABMN, and we can shift this 2 which is present here division also to here also. So now this is our equation number first. ABMN is equal to the double of MBC. From the second result we already proved that area of BYXD is also equal to double of MBC. So these two are equal to each other in area. So student, this is your third part. Students, fourth part is same as first part, fifth part is same as second part, sixth part is same as third part. You have to try to prove them. And the sixth part is the combination of third and the second part. You have to try to prove it also. So students, this is very important and the easiest question, but it is a lengthy one. So you have to try to prove all the remaining parts. If you have any doubt, then please told me. I will solve the remaining parts in your next lecture. So students, have a nice day. Now your homework. So student, this is your today's homework. Do questions of exercise 9.4 from NCERT in your homework notebook and do examples. You have to do exercise 9.4 in your homework notebook and examples in your practice notebook. You have to send pics to me on my email ID for your homework. So students, this is today's lecture. Thank you. Have a nice day.